The activity you're going to do for Section P3 is going to teach you about probability. Specifically, you're going to learn how to calculate probability by doing a simulation. And then you get an estimate of a probability by looking at the long-run proportion of successes in a simulation. We're going to look at a game show called Let's Make a Deal. It's a game show from the 60s. And the premise of this game show, is there's a lot of things going on in this game show, but one of the things you could do in this game show is try to win a new car. Now, to make things interesting, there were these prizes that weren't worth anything. So for the sake of this illustration, we're going to call those no-good prizes goats. And the 3 prizes were hidden behind 3 doors, and the game was simply, which door do you want? The game show host, Monte Hall, would ask you, do you want door number 1, door number 2, or door number 3? So you know how probability works from junior high or grade school or whatever, so it's a 1 out of 3 chance of winning the car. But let's pretend we didn't know that. We could get at the probability by running a simulation. So by a simulation, we use coins or cards or something to simulate how the game works. So in this case, we have 2 black cards and 1 red card. So the red card is the car. We shuffle those cards and we draw one at random. So there, we won a car. So we write that down as we won a car. And then we keep simulating over and over again. So we do a bunch more simulations. We see, do we win a car or do we get a goat? Do we lose? And we keep track over the long run of how many cars that we win. So you can imagine this going on over and over and over again. And in that table there, we're going to keep track of how many cars we win and how many times we get a goat. In other words, how many times we lose. And what we should discover is the proportion of times that we win a car should be roughly the probability that we win a car. So you can get at it. So in this case, 7 over 22, that's about a third. You can get at the probability you want by running a simulation. Now, this gets more interesting if we try a different strategy. So this is called the switch strategy. So in this strategy, after you pick the door that you want, the host comes back to you and said, oh, well, look what was behind the door you didn't pick. And when he does this, he's going to show you a goat. And then he's going to ask you, do you want to switch? So for example, let's say you picked door number 1. Okay, then the host says, well, I'm going to show you what was behind door number 3. Behind door number 3 is going to be a goat. So do you want to switch your choice to door number 2? And if you're playing the switch strategy, you'd switch to door number 2 and see what's there. And so we know what's going to happen, right? Door number 2 is going to have a new car. That's the switch strategy. So now the question is, what's the probability of winning with the switch strategy? So we can approach that the same way by running a simulation. So we keep track of how many cars we win and how many goats we win. And we do this with cards. So pick door number 1, then you have to have a partner who knows where the car is, who's going to show you a goat, and then you switch and you pick door number 3. And so in that case, you won a car. And so you tally that. And you keep doing this over and over and over again. So you keep track of how many cars you win and how many goats you win, and you see over the long run what the probability of winning the car is with the switch strategy. Now that can get kind of tedious with cards, so what we're going to do is use an applet from the textbook website. So here's the textbook website, and here is the Monte Hall applet. It's named after the host of the game show. And notice on the Monte Hall applet, it lets you play either the stay or the switch strategy. So here I'm playing the stay strategy. So I'm clicking on a door and I'm staying with my choice. And notice I'm losing every single time, even though we know the probability of winning should be a third. Now what the applet can do for you is run this over and over and over again. So I can tell it to run the stay strategy over and over and over again. And look what happens. It's keeping track of how many wins I get in that long run total. So there's a cumulative win proportion in that graph there. And then there's a running total stay and switch that's telling me with the stay strategy how many times I'm winning, right? So I'm playing the stay strategy and I'm winning about a third of the time, 32%, 31%. So that's what you do with a simulation, is you run the thing over and over and over again. And from that, it's going to tell you what the true probability of winning is. Now, what you're going to do in the activity is experiment with the switch strategy. So just remember how the switch strategy works. So I reload this applet. And now if you play the switch strategy, you pick a door, right? So pick door number 2, and now you switch, and look, I won a car. So you can play that again. Pick door number 2, switch to door number 3. Oh, that time I lost. Play again. So again, you can play the switch strategy over and over and over again, or you could have the applet do the switch strategy for you and repeat that several times. So I won't do 1,000 times. I'll leave that fun for you. I'll just do like 5 times or so and see what happens. So notice you do it 5 times. Oh, you win more often than you lose. That's interesting. So part of the idea here is when you do a simulation, if you do a simulation over and over and over again, the more times you run the simulation, the more accurate a result you get for the estimate of the probability. Okay, so that's it. Have a look at the exploration for section P3 and then write up the answers to all the numbered questions and hand those in on Canvas.